VP of Engineering at ChainSafe, and I'll let them take it from here.
Awesome. Thanks so much. Sorry, let me just get my windows organized. Awesome. Hey, everyone. My name is David Ansermino, and I am VP of Engineering at ChainSafe Systems. We are a 60-person blockchain R&D shop founded in Toronto, Canada. Today, I'm here to introduce the Rust implementation of the Mina protocol that we've recently begun working on. First off, let's take a look at some of the goals for this project. Our primary goal is, of course, to build an alternative implementation of the Mina protocol. By increasing the diversity of nodes on the network, we aim to increase the resiliency of the network. Our second goal is to target additional architectures, specifically ARM and WASM. This will enable us to run Mina nodes in embedded and in-browser environments. Our third goal is to motivate the development of a complete specification. While this will most likely reflect the reference implementation, it should make it easier for additional implementations to be built. Through this process, it's very likely that areas of improvement will be identified either within the reference implementation or the protocol itself. Now let's answer some of the questions that you might have. Why Rust? Rust is the most loved language in 2020, according to Stack Overflow's developer survey. It's well known for its excellent performance, its memory safety, and concurrency. It has a strong, community-driven, open development process, which is very active. It has some of the best language support and tooling for WASM, and it's already being used by a multitude of protocols for their primary or alternative implementations. Why WASM? Well, WASM is formally described as a binary instruction format for a stack-based virtual machine. The format is very compact, making it very portable. The primary use case for WASM is to provide a safe execution environment within web browsers, which has comparable performance to running native software. This allows more sophisticated applications to be executed within a browser. However, since its inception, a number of other use cases have been identified outside of browsers and web applications. Why ARM? Well, ARM is a processor architecture that dates back about 30+ years. Compared to the more common x86 processors used in most computers, ARM processors have a lower cost, consume less power, and produce less heat. They are very commonly found in IoT devices, as well as other SoCs. Many of you have probably heard of the Apple M1. That's an ARM processor and a great example of the strengths of this architecture. So why ChainSafe? Well, our company mission is to realize the potential of Web3 technology through sustainable open source development. We see huge potential with Mina in driving the blockchain space forward, and we are very proud to be supporting the development of it. We have great experience building protocol implementations. In addition to Mina, we're currently working on implementations for ETH2, Filecoin, and Polkadot. As an open source first organization, we have a strong commitment to supporting community-driven development. Now let's look at our current roadmap, which is very incremental. After building the serialization primitives, we'll move into implementing the block selection algorithm. Then we'll be implementing block verification, and after that, we'll be adding support for the ledger state and some additional state objects. Finally, we'll be building out libp2p support in the browser so that the node can receive blocks and submit transactions. At the end of these initial milestones, we'll have a non-consensus node, which can run in browser. Although it won't yet participate in consensus, it can be used in browser-based applications to interact with the Mina network. For many protocols, this would be considered a light client. But thanks to the design of the Mina protocol, this will actually have the same security model as a full node. We hope to continue this implementation and eventually complete a full consensus participating node. This project is still very young, but let's take a look at some of our progress so far. For that first serialization milestone, we have built Serde bin prot, which can be found in this GitHub repo. It's a Rust implementation of the bin prot protocol using the Serde framework. It's still experimental, but has almost complete functionality. Next up, we're going to be implementing the block selection algorithm. You'll be able to follow along with our progress in our GitHub repo, chainslave/MinaRS. Meanwhile, we'll also be working on a better name as well as some branding. That's all I have for you today. Please feel free to reach out to me on Telegram or Discord if you have any questions or feedback or interested in participating. We also have a channel in the Mina Discord called ChainSafe Rust Client, where you can reach our team. If you love Mina and you love Rust, we would love to hear from you. Thanks so much for watching.
Awesome. Thanks, David. Let me just share my tab here. Okay. I'm assuming people can see this. David, just unmute yourself and tell me otherwise. Cool. So, right. So I'm Brandon. I'm the first engineer at O1 Labs, and I'm here to talk about all the engineering work that's been going on our team since mainnet. So this can be broken up really into two categories, I think. One, just general changes to the Mina daemon itself, and the other is the work on snaps. So we've done so much that I cannot possibly talk through everything, but I made this nice slide to sort of help show what's going on. Basically, there's a release that's coming very soon, and there's a current alpha build where you can play with it on a devnet or testnet. And I'm just going to walk through some of the new things. So on the all the way on the left, you see the GraphQL and CLI features. One thing that we've done is we've added a new VRF command that allows block producers at the beginning of an epoch to figure out exactly which slots that they are supposed to win. That the VRF, the verifiable random function, will tell their node that they've won a block. And not only can block producers use this information themselves to have a better understanding of when they're about to create blocks, but they can even produce a file that can prove to others of when they're supposed to make blocks. And perhaps the community can build a tool that helps rank block producers and helps rank staking pools using this information. Another thing is we added a command to hash transactions that was just missing, so it's there. There's a new flag to specify a minimum block reward amount when you're creating a block. And this is useful to protect against the case where your node has just restarted, you haven't received enough snark work, and someone tries to slip in a snark work that's super expensive. Then finally, on the GraphQL and CLI side, we've added an API to detect stage ledger proofs being emitted from blocks. And this is like the complicated concept, but the general idea of it is this is when the transactions finish being snarked by snark workers and are actually added to the snark part of the blockchain. And it's important to know this because this is precisely when the information is checkpointed for the purposes of staking and delegating. So with this API, you can figure out exactly when the last time that this happened before an epoch transition and better understand what's going to happen in an upcoming epoch. On the stability and bug fixes side, one thing that we've done is optimize the way that the Mina daemon verifies snark work. So this happens in a separate process from the main Mina daemon. Basically, the optimizations make it so that the Mina daemon can spend more time and energy and compute power doing all the other things it needs to do rather than communicate with the snark verification process. We've added more verbose logging of long async cycles. This will help O1 Labs and the community better understand where these bottlenecks, which trigger these long async cycles, are in the code base, so that we can prioritize and fix them. We've also added more aggressive snark work rebroadcasting logic to nodes. So if your node is creating snark work and you want to sell it on the Snarketplace and you want block producers to see it, well, it's really important that you get your message out there. And now it's more aggressively sent. Another thing is we're chunking transaction rebroadcasting now. So what this means is if you have sent a ton of transactions from your node in a really short period of time, if you're not careful, you can overload other nodes on the network and sort of get them to stop listening to you. It won't actually break them, but they'll just ignore your messages. So now your node will be smart about the rate at which it sends those transactions out, and it won't overwhelm the other nodes, and everyone will listen to you. And finally, we've fixed an out-of-memory error that is happening from time to time based on an issue with the zero knowledge proof library. It's very complicated, but the point is, on the alpha, we haven't seen this bug, which is really exciting. So on the last category here, one thing I want to highlight is there have been 57 pull requests that have landed that improve monitoring and alerting of the Mina network. And what this will do is it will make O1 Labs, at least from the perspective of what our nodes see in the network, better understand what's going on and be alerted in the case of anomalies, so that we can take action urgently if necessary. We've added a feature to the Rosetta, which is the open interface or the open protocol that allows information to be extracted from different blockchains. So Mina implements Rosetta, and now it supports querying for both liquid and locked balance lookups on chain. And then finally, we have now support for creating alpha builds, one of which is linked here and has already been released. And the alpha builds are intended to be used on devnets and testnets. When we feel that the alpha is stable enough, we'll promote it to beta. Beta is intended to use on mainnet, but not have all the nodes upgrade all at once. And once we think that is stable, then we'll do an official release. And just before I move on here, I want to give a shout out to Andrew at the O1 Labs team for making incredibly amazing release notes. If you haven't seen them, you should. This slide would not have been possible without those release notes existing. So that's the Mina daemon. If we go over to the snaps, this is just a glimpse into the stuff that's already been completed on snaps. So one thing is we have zero knowledge proving that works in the browser fully. So you can prove snarks in the browser. All right, that's one piece. The other thing is not only can you prove them, but you can actually implement snark circuits using TypeScript or JavaScript in the browser and then prove them. And even that's working. There's an RFC out for the new transaction model that's needed to support snaps in the protocol. I'll just skip over a few of these things. There's a better hash function. And then finally, there's a ton of progress on HTTPS snaps. This is this concept where public websites or websites that have public data behind an HTTPS certificate we can kind of get that data on chain on Mina without the website really even having to do anything to integrate with Mina. So it's super, super fascinating. Cool. Looking forwards, the 2021 priorities, the same thing that we talked about at Illuminate. We've already made a bunch of progress, but O1 Labs wants to enable the developer community to build and contribute to the ecosystem. In doing that, we're helping to support the Rust implementation that David talked about, ChainSafe is working on. We're working on snaps and various tooling associated with snaps and with Mina. And then we're putting a lot of effort into improving performance and fixing issues with the daemon in order to improve performance on the network and to reduce hardware requirements for running nodes. Yeah, and there's gonna be a blog post describing our priorities and the 2021 and 2022 roadmap coming really, really soon. So that's that.
Awesome. Thank you so much for this. We're going to transition to our next session now.